So I came today to talk about building systems that can improve their own code and their own functioning. I got into thinking about this because I work in the security AI research team along with Michael, and I started thinking about the work that our threat adversaries are doing as they try to build a persistent presence in Microsoft's networks. And if they aren't already, my conclusion is that they very soon will be building agents that can improve their own code in order to maintain that position. So we in Microsoft spend a lot of time thinking about how we can build agents that are more autonomous, that can sort of evolve and adapt to the situations they encounter. And for me, that's a super depressing arms race. So I got to thinking, is there a better way? Can we do something different, right? And for me, this idea of programs that can learn and evolve along with you, it goes all the way back to like my first computer that my parents ever got me, which is like a Radio Shack TRS-80. I remember my expectation as a 5 or 6 year old was that that thing would be on a learning journey with me. And it turns out that the computer, learning assembler on its own wasn't going to happen in the early 80s, but I've kind of pursued that passion ever since. And I think about this, the possibility with LLMs and agents is so tantalizing that, it's sort of, we're on the tip of being able to treat our work output, the agents that we build, et cetera, as if we're bringing them up, raising them to go out into the world and do work, and preparing them to be able to do that work well and to continue learning as they go. For me, that's super exciting, and that's the compiler that I want to build, right? And so this has become called agentic software engineering or agentic engineering, and it's very similar to how we have designed software for the last 40 years. But there's a few things that are changing about the flow and about how we do it. And part of that is that intelligence is both a tool for building our agents and our programs, and it's also a design element of those agents and programs. And these are two pieces that have not been true for most of my career as a programmer. And so this yields some interesting changes in how you approach what you build, right? Writing the code itself is a lot less interesting than asking questions. And that leads you on a journey for exploring all kinds of different paths towards the solution you want to get to, right? And your job as the agentic engineer is to leverage the agents you're building, the LLMs you're working on that journey of exploration, right? And to put them together into new patterns, new ways of doing things. That kind of recursive process of involving the agents that you're using in the design of themselves is actually a really important part of how you start to accelerate the work that you do. And so at the end of the day, like, this becomes thinking about thinking, like, and so a lot of the science for how we will end up doing this well at scale, I think, is going to come from what we've already learned as a society about how to structure complex projects, right? Whether it's designing the Apollo program or building complex public policy, negotiating peace around the world, et cetera, right? Where we get large groups of human experts to think and collaborate on complex work. Those are the patterns that are going to help us build ever more sophisticated AI systems. And so within the scope of the agents that you're trying to design, the problems, the questions that a PM is going to ask in a software development team, those are really important to everybody on that team now, right? What problem am I trying to solve? What outcome do I want? How do I get to a quality solution, right? And as you're doing that, is there any part about this process that you can turn into tools that your agents can use, right? And we'll talk more about that. But like, part of this structuring how you're thinking as you move through agentic design is going to help you figure out how to structure the agent in such a way that it can do that kind of thinking and ask those kinds of questions as it builds new components for itself, right? And at the end of the day, this really reminds me of a lot of the challenges that were involved in building cloud in the first place, right? cloud scale global systems are possible because we dove deep into how to build reliable systems out of unreliable components, whether it's storage, network, compute. And in this case, it's the unreliable component is the LLM, which is subject to hallucination, which is trained on a limited data set, et cetera, right? And how do you compose that LLM as an element into a more complex system and get more reliability out of the resulting system than all the pieces that it's built from, right? One of the things that I've learned in doing this repeatedly is that you may start with a prompt and use that prompt a few times, refine the prompt, change it, build it into your program. But eventually, over time, the prompts that are good become commands or workflows that you can use repeatedly, right? And they end up being things that the LLM can call itself to then dive off on a particular aspect of the workflow. Once you start doing that, then you'll have patterns for workflows that you use again and again. Here, a simple pattern would be the workflow of starting a new code file with a specification, and then defining the API, and then writing the code file, and then running your pre-commit hooks on that code file and running all the tests, and then going and fixing everything you found, and then checking it in, then pushing to GitHub, right? And so it starts to be, one piece of the development workflow of the whole thing, right? And that becomes then a pattern that can be used again and again by your agents as you're building code, if building code is your objective, right? And so this kind of thing, going in a loop, right, yields building more and more tools that are built on one another, right? And so, as an example, one of the hardest parts in evaluating AI written code, right, is doing that end-to-end test the way that a user would. So what does it mean then to build up an agentic system that can do that kind of outside-in testing? And that's sort of like the next more complex workflow and the next piece that's further out from kind of that inner loop, right? And where I lead with this is that the advent of agentic coding is sort of a waypoint. It's a stepping stone on the way to building self-improving programs, right? We suddenly have all these new capabilities that we didn't even just a year ago in terms of producing vast amounts of relatively sophisticated, high-quality code. And there's a lot of problems with it. The problems lead us to start to put a bunch of pieces for solutions in place. And in part, that's sort of what are all the guardrails we need as we generate code with agents in order to try and ensure quality? What are the structured reflection loops where the agents can be instructed to look at the work that they just did with a different point of view or multiple different points of view, and then try to reconcile that with where you want to go and the quality gates that you establish, right? What are the playgrounds where you can run those agentic end-to-end tests that sort of evaluate the work, give feedback to the agents, let them go, and then structure how they approach making a new solution, right? By turning to recursion and feeding all of these questions back into the coding systems that you're building, you will come up with the structures that are on the right-hand side of the slide, right? And it will start to help you build the pieces and the tools that are necessary to make agentic coding accelerate itself, right? There's a lot of different ways to think about what self-improvement means in this context, or what the sources of self-improvement are. Right? It can come from trying to ensure zero bugs. Right? It can come from creating goal-seeking agents that, their job is to achieve a particular objective. Like I built some agents the other day where what I wanted was for them to get to a particular Azure setup with 5 or 6 resources that were related to each other in a certain way. And I didn't really care about how they got there. I just gave them a goal and then told them to iterate until they got there. And that's one way of kind of improving the system overall. I'm particularly interested in design thinking as a vector for self-improvement, and bringing the kind of design thinking techniques that we use in the classroom or in product design into the agents themselves. And so my colleagues at Microsoft have been doing some interesting experiments around that, right? The AI world has for a long time experimented with genetic algorithms as a way to mutate a program in order to try and identify improvements. I think that's a lot more fraught, kind of difficult in this LLM world, but it happens from time to time, and it's one tool in the toolbox you could turn to. Similarly, there's lots of other vectors here, right? Whether it's user customization or finding things that were working well in other programs and bringing them into the program that you're working on, et cetera. There are techniques that can be used to pursue an objective for self-improvement. And I'm sure this is not a comprehensive list. I think other folks may come up with ones that are interesting to them, right? To get to a world of self-improving programs, there's a lot of big problems to solve. And so I think this is a really interesting space where all of you that are agentic engineers can be working, innovating, playing, and we don't have all the answers. And I think it's really fun to be in that space. That's why I have done computer science all my career, and why I'm more excited about it now than any day since I opened that first computer I was telling you about, 40 plus years ago. I think the testing and evaluation is one huge problem, where we can generate so much more code now that we have to write agents to sort of pretend to be users to help us test that code, right? I think we still don't know all the UI patterns or ways of interacting with agents that are necessary to really help them be able to learn from us or with us. And so there's some exciting things to answer there, right? How do you know whether something is actually improving or not is also pretty interesting, especially when it's something that's relatively autonomous with somewhat nebulous goals. And even framing for the agent what the right way to think about that is can be really challenging, right? And then, I think there's an interesting spot too, is when the biggest companies in the world achieve the ability to build programs that can improve themselves with user feedback, with quality at scale, I think it really changes the economics of everything that we're doing, right? And I would not want to be running a traditional SaaS company at the point when that happens, because I think any large cloud player at that point is suddenly able to replicate your SaaS very, very quickly. So that's a really interesting kind of inflection point. As soon as the ability to really do self-improving programs is achieved, I think it's going to be very disruptive for the whole industry. I think there's a lot of interesting implications for how we design human in the loop here, and where if we bring together agents to help facilitate workflows where experts collaborate, what does it look like to have humans in the loop to help guide and have those agents work on their behalf, collaborate with colleagues on their behalf? And there's interesting challenges there. My mental model for it is that this ought to be a spiral where initially most of the collaboration happens between AI agents, and as it gets further and further from the initial idea to more detail and more resolution around the problem, the human experts with the deep expertise and the tools that are outside of the AI agent system start to interact with each other and with the agents more, the wider that spiral gets from the middle, and the more defined the problem becomes. Again, at the end of the day, there's interesting societal impacts for self-improving programs. And this is really exciting for me when I think about the potential impacts for product design, for education, for building effective government policy, all kinds of different things that we're giving the systems that we build the ability to improve themselves and measure that improvement will unlock the next big stages in society. And then so as the builders of these systems, then how do we work on leveraging that technology and adapting to all this change? Fascinating questions here. And there's one more that I want to pose, which is if you're a developer building a program that can go out into the world and add to its functionality. Right? It brings up the sort of old ship of Theseus problem, which is once a thing has been rebuilt completely, at what point is it no longer the same thing, right? And whether it's a service that you've deployed into the cloud that's now changing its topology to adapt to attacks, right? Or if it's a user program that has customized its interface to adapt to the user's preferences so thoroughly that is no longer effectively what it was that you sent them, right? Then the representation of what's the canonical thing you're shipping is really something different, right? What you're shipping is intent. It's a representation of a set of solutions or tools for solving a problem rather than a specific solution to a given problem. This is a new way for a lot of us to think about the programs that we're building, right? And so, I've been pushing the boundaries of what we can do with agentic coding sort of continuously for the last 3 years. And one of the things that I want you to take away from this talk is, as developers, we've been taught to that the code we build is important, right? And once we've written code, it's really difficult to throw that away. But I think AI-driven coding, especially agentic-driven coding, changes all of that. And across all the time I've been working on this, I've never regretted throwing out the code I have and starting over, which is a newish feeling as a developer, right? And so that is just something I want you to take away from this session, is that when you are building agents whose job it is to sort of get better and learn with you as you go, it's important to be able to throw that code out. And the other thing that I threw in here is, at Microsoft especially, there's no shortage of people who will tell you that what you're doing is too ambitious, or that it doesn't fit with where we're trying to get to right now. And for me personally, I often take that as a sign that I'm on the right track and I'm going the right direction. But as with all things in this world of AI-driven progress, it is important to exercise our skepticism and to hold both ourselves and our work output to account. And you'll develop over time, the more agentic coding that you do, a strong intuition for when the model's lying to you, or when you need to ask more questions, or when you need to go deeper. And it's just a reminder about that. Yeah, and so lastly, I think we're at a really interesting transitional stage here, where vibe coding is all the rage, and spec-driven development is what everyone talks about. And I encourage you to frame that as a waypoint, right? That's not the destination. I think that moving towards systems that, once we bring them into being, can continue to improve themselves is the right way to think about where all of this is going. And so as product builders, as engineers, then it's our job to start thinking about how to embody the intent for the systems that we're building into the program itself. And those requirements become the guardrails, the structure, the frame for what the program is, right? You can imagine, for instance, you don't want a self-improving program to modify the building system, right? So you need to put some guardrails in place around that, so that that part of the code is never touched by the coding agents, except when explicitly instructed to, right? And there's plenty of things like that where putting boundaries around these things is now a really important part of what you're doing. The other thing I would love you to think about is I've raised a lot of questions here and sort of called out a bunch of benefits and a bunch of problems. My point is, I think all the pieces we need in order to build really exciting self-improving systems are right here. They're on the table. And it's our job to just start putting them together piece by piece. And I think that's really interesting.